Alright, welcome to Academic Digest class. Today we're treating logarithm. We say the logarithm of a number n to a base x is the power a to which x must be raised to give n. This is the common definition you normally see on most textbooks, and to an extent it's confusing. If you understand this one now, this is the summary. I said we can simply put it that logarithm is the power of a base to yield given number. So when I have indices, for example, 2 raised to power 3, I know that it will give me 8. 2 raised to power 4, I know it will give me 16. Shebi? So we are saying that raised to power, that when you take the raised to power, and you are now considering it to be a base, that is what is raising it to that power to be a base, we can say that power of that base is the logarithm. So which means that 4 is the log of 16 whenever the base is 2. Which also means that if I have 4 raised to power 2, and I know that 4 times 4 is 16, which means that 2 is the logarithm of 16 whenever 4 is the base. Are you seeing it now? So the goal here is to simply get the point that whenever you have a base, what can you do to the base? What can you add as the power of the base to get the given number? So if they give me log 8 to base 2, I'll simply ask myself, what do I do this to this 2 so that I can get 8? And that is why you see most books, most explanations, when they are explaining this, they say, as they are trying to get what do you do to the power of what do you do to the base, which is 2, to get 8. And when you don't know it, you simply call it x, and you want to get 8. So in this case, you will now do, this is x. How do you make 8 have x? This is going to be 2 raised to power 3, 2 raised to power x. And you remember indices, bases are the same, base law. So x is equals to 3. So x is equals to 3, which means that the logarithm is 3. So the power of a base, that thing you need to add to the base to get whatever you are given, is what we call logarithm. So log, down here it said log 1 over 27 to base 3 is equals to minus 3. And you know that 3 raised to power minus 3 is 1 over 27. So it's simply the same thing as saying 1 over 3. Yes, 1 over 27. Let me bring it out. What do I add to this base, which is now the same thing as saying 3 raised to power x? 3 raised to power x. What do I add as the power of this base in order to get 1 over 27? Are you seeing it? This is where I can say 27. This 1 over 27 is the same thing as saying 27 raised to power minus 1. And if I know that 27 raised to power, remember that everything is still equals to 3 raised to power x. Then I'll ask myself, this, how do I get this to become the same base with this? Because I can see that the lowest base is 3. So let me reduce this one to its lowest base. Very important. So this is something that's saying 3 raised to power 3 and is having minus 1. So this is 3 raised to power minus 3 is equals to 3 raised to power x. So you can clearly see that since the bases are the same, the power should be equal. So minus 3 is equals to x. So which means that when you have this log 1 over 27 to base 3, that the power to be added to this base 3 in order to get 1 over 27 is simply minus 3. So if I come and carry minus 3 now and add to this 3 that is here, 3 raised to power minus 3 is the same thing as saying 1 over 27. Alright, so you now know that logarithm is, indices talks about power of variables or numbers, while logarithm talks about power of a base. Yes, so it talks about power of a base. Alright, so if I know that, let's try to solve certain questions. So the simple questions given to us here. I have problems. Evaluate log 1 over 3. Let me write it out. Evaluate log 1 over 3. Sorry, log 1 over 9 to base 1 over 3. Very important you know how to put this thing. Then they also give me, okay, let's solve for this one first. So trying to evaluate log 1 over 9 to base 1 over 3 is simply the same thing as saying bring out what you are given, which is 1 over 3 as the base. What do I need to, how do I raise, or should I say, what do I add to this base in order to get 1 over 9? And the way to go about this is simply saying, notice that this is 1 over 3, and in this he said that anything raised to power 1, anything having 1 as the numerator is negative power. So this is, and notice that this one now, this is raised to power x. Notice that this one right here is the same thing as saying 9 raised to power minus 1. This one is in its lowest form. This one, let's take this to its lowest form. The goal of indices is related to logarithm a bit, because you'll be trying to check anywhere you see a particular value that is not in its lowest term. So I said anywhere you see a particular number that is not in its lowest factor, you take it down to the lowest factor. So this is the same thing as saying 3 raised to power 2 raised to power minus 1. Power law, this is the same thing as saying 3 raised to power minus 2 is equals to 3 raised to power minus x. Now, since the bases are the same, the powers should be equal. So that means that what I need to add to this base in order to get 1 over 9 is simply 2. So let's try and check it. I have 1 over 3. If I come and add 2 to it, let's check. You see that I will have 1 raised to power 2 all over 3 raised to power 2, and then 1 raised to anything is 1 all over 9. For there? So you see that we've gotten that same thing. So that is for question 1 given to us. Let's go back and check the second question. They said evaluate log 0.2 to base 5. Log 0.2 to base 5. Now notice that 0.2 is the same thing as applying standard form, secondary school, decimal points, all those things. This is the same thing as saying 2 over 10. So this can also be written as log 2 over 10 to base 5. So if I know this, I can simply check 2 go 1 2 go here 1, 2 go here 5. This is the same thing as saying I'm trying to reduce it to lowest form before I start solving anything. Log 5 then 1 over 5. And I know that 1 over 5, anytime 1 is the numerator, it means that the denominator is having a negative power. So this is something I'm saying log 5, then log 5 raised to power minus 1 to base 5. So this is what I have. This whole expression first is this before I start applying knowledge of logarithm. So what do I add to this base in order to get this 5 raised to power minus 1? And that is where we say, once you are thinking of what do you add to the base, simply bring out the base, raise it to power x. Anytime you don't know anything in mathematics, you call it x or y or any variable. So equals to what you want to find, 5 raised to power minus 1. Now notice that for the fact that these bases are the same, the powers should be equal. So x is equals to minus 1. Let's check if it's true. Notice that if I come here that I have 5, let me bring out the 5. And then I carry this minus 1 and put on top of it. 5 times minus 1, it gives me the same thing. So x is equals to minus 1. Let's check for the next question. Let's look at the next question. The next one says log 16 to base root 2. That is log 16 to the base of root 2. That is square root of 2, which is root 2. Alright, so let's try to solve it. They said log 16 to root 2. You first need to ask yourself, what is root 2? This root 2 is the same thing as saying 1 over 2. That is 2 raised to power 1 over 2. Remember indices. Indices says that if I have log 3 cube root of 3, or less ahead, that this is the same thing as saying 3 raised to power 1 over 3. And if I have log 3 raised to power 1 over 3, or if I have, let's say I have a raised to power k over m. Indices say that this becomes mth root of a, all raised to power k. The denominator becomes the root and the numerator becomes the power. So applying the same principle here, you can see that this is the same thing with this. Root 2 is the same thing as 2 raised to power 1 over 2. Denominator becomes root, numerator becomes power, and anything raised to 1 is nothing. So this is log 16 to base 2 raised to power 1 over 2. Now the question is, what do I add to this base in order to get 16? So first of all, remember that I have 2 raised to power half. And whenever you say what do you add, the principle is simply, as you are thinking of what do you add, since you don't know it, what do you add to the power? Logarithm simply means power of the base. So the minute I bring out the base and I put x as the power, I'm still talking about logarithm. You know, sometimes when you're looking at that log, it makes it look as if it's something big, or it's like a road block. No. So once I know that power of base means logarithm, I can simply bring out the base, raise it to power, and I don't know the power yet, so I put x there. Is equals to what I'm going to find, which is 16. Are you seeing it? So you will now see that we'll ask ourselves, what is the base? If I reduce 16 to its lowest, it will become 2 raised to power 4 is equals to 2 raised to power x over 2, because x times 1 over 2 is x over 2. So you can see that this is the same thing as saying 2 and 2, they have the same basis. And since the bases are the same, the powers are equal. So I have x over 2 is equals to 4. So you can clearly see that x will now become the same thing as saying anything standing on its own is over 1, cross multiply, x will now be equals to 8. So what it means is that what I need to add to this in order to get 16 is 8. That is to the power. In order to get 16 is 8. Let's check it. I said that root 2 is the same thing as saying 2 raised to power 1 over 2. Now let's say I come and add 8 to this. You see that this will become 2 raised to power 8 over 2. 2 here 1, 2 here 4, which is the same thing as saying 2 raised to power 4, which is equals to 16. So what if you notice everything we've been solving here? If you notice, like if you look at everything we've solved so far, like it goes to say something. Like if you observe everything we've been doing, if you observe everything we've done throughout, it goes to show you that whenever you have a number n equals to, let's say, ma, if I have a number n equals to ma, what he's saying is that this will become the logarithm. That is the power that must be added to the base to get this. So if I have n equals to m, is the same thing as saying log m, then I have n, that is log n to this base must equal to this, which means that when I bring out this now, and put a as the power, it gives me n. So what I'm saying by logarithm is that if I don't have this to be log n to base m to give me this, I can also write everything here, everything I have here, as the same thing here. So once I know that the base raised to a power will give me the number, the given number, I can choose to replace it. It will take care of the logarithm that I'm seeing here. So whichever way you want to understand this, it becomes easy. So, but the simple idea is that logarithm is simply talking about the power of a base to yield a given number. The power of a base to yield a given number. And that power is this. So logarithm talks about everything here. That's why I normally tell my students, once you see this kind of question, take it to this so that it becomes easy for you to solve. All right, so let's move to the next question that we have. Next question says, state the laws of logarithm. Okay. Question 2 states the laws of logarithm. Remember to subscribe to the channel. That's what you should do. Once you enter, you're supposed to, if you're somebody that wants us to continue making videos and enjoy what we're doing, once you enter, you just subscribe. You like, so that it will be entering your head. So state the laws of logarithm. All right, I need you to remember that whenever we are trying to do this, we're always thinking of the same principles that we've come so far. What will be there for multiplication? Multiplication law. What will be there for division? It's just like the same way you do life. When you come, there are protocols. So what will be there for power? Then what will be there for fraction? What will be there for zero? What will be there for negative? So it's just like the way you treat life. So what are the protocols? Okay, what would be there for negative power? Sorry, let's use it this way. And what would be there for zero power? Yes. And what would be there? What would be there for inverse or reciprocal? So it's the same approach, the same mindset of indices. And what would be there for bases when the bases are equal? Or when I just have instead of using base law, instead of calling it just base law, I can say what will be there for equality. What will be there for equality? So you see, let's now put this now. So for multiplication, we have that if I have log a plus log b, that it is equal to log a times b. Are you seeing it? So instead of coming to do log a plus log b, stressing yourself, just bring out one log, then do a times b. If you remember, in indices when we used to do a times m n, that this is the same thing as saying if the bases are the same, if the bases are the same, we simply do a raised to power 2 plus n. So logarithm is now saying if the bases are the same, that you should just choose to use one log, because you know that log is talking about power. Then you now do a times a. Are you seeing it? So now that you know that, so that is what you have for multiplication law. Now for division law, the same principle. If I have log a minus log b, and notice that there is no like limitation, I can see log a times b somewhere. I can see log a times b somewhere, so far as the log is the same. And anytime I have log, they did not indicate the log, I just know that it's in log 10. I need to know that unless specified. So far as the log is multiplication or addition, I can choose to take this to mean this, or I can choose to take this to mean this, depending on what gives me the answer I'm looking for. So log a minus log b is the same thing as saying log then a over b. All right, now remember, for distributive power. So now for power law, if I have log a raised to power 2, if I have log a raised to power 2, the principle is saying that this is the same thing as saying 2 log a. So for example, if I have log m raised to power n, this is the same thing as saying n log m. You need to know that. All right, now let's say I have fractional. This one is talking about fractional power law. So let's say I have let me find the perfect example for this. Let's say I have okay, let's say I have, for example, I have log a raised to power n over m. So you can see that this log n over m will become the same thing as saying n over m log a. So you can see that the only difference between this power law and fractional power law is just that it's fraction moving. All right, so I think as we start solving question, we'll see perfect example where we put this to good use. So now if I have, and also if I have, for example, let's say log n 2.2, I need to always convert this to fraction. I can't use decimal. So this is the same thing as saying log n 22 over 10. So I need to always convert this to fraction. We make use of fraction and not decimal points. All right, for zero power law, let's check. If I have log of 1, let's say to base x or to base 10, we know that log of 1, this thing is the same thing as saying what do I add to this x to get 1? And this will simply be the same thing as saying bring x, raise it to what I don't know, which is, let's say in this case, x or y is equals to 1. How do I get 1? And I know that anything raised to power 0 is 1. So x raised to power 0 is equals to 1, which means that log 1 will always be equals to 0. So what it means is that anytime I am given any value raised to power 0, it is the same thing as saying log 1. So 2 raised to power 0 is the same thing as saying log of 2 to any base raised to power 0. So log of 1 means 0, or anything raised to power 0 is the same thing as saying log of 1 to certain base. So I hope this is not confusing. If I have, see what I mean? If I have 2 raised to power 0, I know that this is 1. Is it not true? So what I'm saying is that this simply means log to any base of 2. Log to any base of 2. So let's say this is log of x to 1. this will give me 0. I know you want to say what of the 2? What of the 2? Even if I come here and put this to be 2, provided that the log I have here is 1, I must raise this to 0, because 2 raised to power 0 is the same thing as saying, watch, log 2, log 1 to base 2 is the same thing as saying, what do I raise 2 to in order to get 1? And that is simply doing 2 raised to power 0, which is going to give me 1 equals to 1. That is what I mean. So log of 1 is 0. So I normally call this the 0 law, not power. So for indices you call it 0 power law, but for here you call it 0 law, or you say log of 1. So then for negative power, I know that if I have let's say log n m, notice that log n and log m to base n, I don't know what this thing is talking about. It's just like they come and give me a question, like let's say I have log 3, log 2 to base 3. Notice that 2 and 3, they have nothing in common. Is it not true? And what this thing will simply mean, I will ask myself, what do I do to the base, which is 3, in order to get 2? So I'll do 3 raised to power x equals to 2. Notice that at this point, this is where most students get stuck, because 3 raised to power x equals to 2, the 2 are in its lowest form. And if you check it very well, you can clearly see that they have nothing in common. So we can now say this log, which is 2, these 2 now, I know that if I add log 2 to both sides, this will simply become 1. So this is the next law we treat. So if I come and say log 2 to both sides, so far as I add to both sides equation, anything equation, there will be no problem. So remember that 3 raised to power x is the same thing as saying log 2 to base 3, because I am saying the power of the base is the same thing as power of the base is the same thing as saying logarithm. So I now say log 2, then 2. Notice that what do I add to? At this point here I have log 2 to base 2. Notice that what do I add to this base, which is 2, in order to get 2, is 1. So 2 raised to power 1 is equals to 2. Are you seeing it? So whenever you have the power to be 1, whenever you have the power to be 1, you say that it is the same value you're getting. So I will come to that when we get to inverse law. So notice that for that reason, this is going to give me simply 1. Then on this side I now have log 2 3 raised to power x. So notice that I can choose to say this is x. I can apply the power law. If this is the power, this can go here. Then I have log 3 to base 2 equals to 1. I can now say divide both sides. Remember that this is log 3 to base 2. It is torque. So we'll say log 3 base 2, divide both sides. So you see that this will cancel. So x will simply be 1 all over log 3 base 2. So you need to know this. So whenever we are thinking of the inverse law, inverse law, or a law that accounts for when the base and the number given has nothing in common, we make use of this approach. So it is going to be the same thing as saying, this is going to be the same thing as saying 1. So notice it's more like reversing. It's more like we reversed it. So this is going to be the same thing as saying 1 over log, here now becomes mn. Are you seeing it? So 1 over log mn. So if I know this, If I know this, the reciprocal or inverse law simply gives the same account. If I have log nm, this can also be the same thing as saying log to m all over log to n. So this is also the same thing. This is also the same thing. So now for Bayes' law or equality law, this particular law, it gives account for when I have for example, let's use this example. Let's say I have a log of x raised to power v equals to log of y raised to power m. So if they give me log of x raised to power v equals to log v to base x and log m to base y, what this law is saying is this, that if since is this way, and notice they have nothing in common, that I should solve this one in such a way that I solve for this separate. So notice that this will be the same thing as saying, let me bring it here, log xv equals to log ym. This will be the same thing as saying solve for this separate, which becomes what do I add to x in order to get v is equals to what do I add to base y x in order to get m. So I solve it separately. So you can see that v now is equals to x raised to power y. That is what v is equals to. And m is equals to y raised to power x. So you need to know that. So what it means is that once you have equality sign, and the bases are not the same, the values have nothing in common, solve it individually, then you can now equal whatever you have. Very simple. So let's move to the last one. And this last one is what we call the distributive power law. So in distributive, it simply means that if I have, for example, log a over b raised to power m, log a over b raised to power m, this is the same thing as saying log a raised to power m all over b raised to power m. And if I have log a times b raised to power n, now this is the same thing as saying log a raised to power n times b raised to power n. So I'll first do this. Very important. So there you have it. So but you need to know about this for the 10th one and the last one. You need to know that if I have log a to base a, it is equals to 1. So log of a number to the same base is equals to 1. Are you seeing it? So log, I normally call this the log to the same base. So when you have the same thing, log a of a, so log to the same base is equals to 1. So if I have a and I have a, as I said, what do I add to this base in order to get this? It is 1. So when I add 1 to this base, when I raise this base to 1, it will give me this thing. So log of a number to the same base is 1. So there you have it. The 10 laws of logarithm. You'll not see it on textbook this way. Not see it in textbook. So you need to pay attention to this video. Rewatch. So every other law that I did not put here, know that is something that as you're solving, you can actually come across. But that 10 is the basic. So let's try to look at this question. They said evaluate. Okay, look at it here. They said, sorry, given log 2 equals to 0.3010. Then, and log 3 equals to 0.4771. Evaluate log 5, 2 log 2 over 5 minus log 75 over 125 plus log 9. So they are giving us many things to solve. So, but the key thing is you get the question. Then we'll try to see what we can do. All right. So I have log 5. Log 5. They're asking me to solve for log 5. And know that once the bases are not given, it means that it's in base 10. So to find log 5 in this kind of case, I have 3, I have 2. So this can also mean the sentence saying, that's why our advice, once you're solving this, you can put it to base 10 so you don't get confused. This can mean the sentence saying log 10 to base 10, log 10 to base 10 minus, notice, Shebi? Yes, minus log 10, log 2 to base 10. Let's check something. Shebi, you know that if I have this, what I mean by that is that this is the sentence saying log 10 over 2. Log 10 over 2 to base 10. Log 10 over 2 to base 10 is the sentence saying log 5. Shebi, that's what they're asking us to find. And I know that logarithm says that if I have division like this, it can mean the sentence subtraction. And why am I doing this? Why I'm using this is because if you check from what I'm asked to evaluate, there's nothing like 10 or 5. But I know I have 2. And I know that log of a number to the same base, log of a number to the same base is going to give me, or log of a number to the same base number or to the same value will give me 1. So that I will now do 1 minus log 2 to base 10. And know that you know that I am giving log 2, which is 0.33010. So 1 subtracted from it will give me that log 5 I'm looking for. That's the idea, that's the concept. And that is going to give me 1 minus this will give me 0.6990. So I've gotten log 5. So let me go to the second one. They gave me to find 2 log 2 over 5 minus log 72 over 125 plus log 9. I would advise you put everything 10 so you don't forget anything. Applying power law, this will be the same thing as saying log 2 over 5 raised to power 2 minus log 72 over 125 plus log 9 to base 10. So log 72 125 over 125 to base 10. So this is going to give me the sentence as saying log 4 over 25 minus log 72 over 125 to base 10 plus log 9 to base 10. Notice that anything standing on this one is over 1. And notice I can apply multiplication law to these two, then division law. So I can have this thing to be the sentence as saying log 10 to 4 over 25 times 9. Then divided by 72 over 125. And you know that this thing now that I have here is the sentence as saying 4 over 25 times 9 times 125 over 72, if you remember. And this, when I do this, this will give me everything up here. By the time I do it, will give me. So punch your own, you should have 5 over 2. So I will now have, since this is division, I will now have this to be log 10, log 5 to base 10 minus log 2 to base 10. And you know we've gotten log 5 before. From here, we got log 5 here, 0.6990. That's what we got log 5 to be. So I'll put it 0.6990 minus minus log 2 0.3010. So by the time I do the mathematics, I'll have 0.398. Alright, let's try to solve the next one. And the next one is giving me this. Log 2 raised to the power minus 1, log 3 raised to the power minus 1. And I know that that is the sentence as saying log 10 to 1 over 2 plus 1 over 3. It's plus that I'm seeing there. So see that this is going to be the sentence as saying LCM 6, 3. 3 plus 2, 5 over 6. Have we gotten anything log 6 here? No. Okay. So notice that this is the sentence as saying log 10 to log 5 over 6, sorry, to base 10. And you need to remember that since it's division, this is the sentence as saying log 5 to base 10 minus log 6 to base 10. And this is going to be the sentence as saying log 3 to base 10 times log 2 to base 10. Because I know we were given, so we are trying to do it in such a way that I know we are given 3 and we're given 2. So I think the best way to do this is not by doing times log, but rather log 3 times 2. See the best way to do it. This is the sentence as saying log 3 times 2 to base 10 minus log 5 to base 10. And we know that we've gotten log 5. We know that we've gotten log 5 to be 0.6990. 69 90 minus. So notice that if this is log A and this is this is B, AB, this is the same thing as saying log 10, log 3 to base 10 plus log 2 to base 10. If you remember our law of indices. So this is the same thing as saying, what do we have for 3? (0.4771). Okay. Okay. This will give me, if you sum this up and sum this up, then subtract this from it. Remember? Okay. Yes. Yes. So remember that this one is carrying log 2, log 10. So we are keeping the logs one side. Now, so if you do this, if you do 0.69990 minus 0.4771 plus 0.3010, punch your own, you will get 0.0791 as your answer. Okay, so let's move to the next question. Next one says we should simplify this. Simplify log 4 to base 2 plus log 1/3 to base 9 plus log 5 to base 0.04. Okay, the way I like to look at this question is simply this way. I will do it, they say simplify, so I will do it in such a way that I have log 4 to base 2 plus log, notice that the bases are not the same. Assuming the bases are the same, I will use multiplication. They have different bases, so I will solve it individually. And we don't like to see decimal points, so 0.04 is the same thing as saying 4/100. So since the bases are not the same, and remember what logarithm is, what do I add as the power of the base to get this? So I'll simply say 2 raised to power x equals to 4, and this is the same thing as saying 2 raised to power x equals to 2 raised to power 2. Since the bases are the same, the powers are the same, x equals to 2 plus, what do I add to this base? 9 raised to power x. Since I don't know the power is our business, equals to get 1/3. And notice that this is the same thing as saying 3 raised to power 2x is equals to 3 raised to power minus 1. The bases are the same. 2x equals to minus 1. So x equals to minus 1/2. This side. I can choose to call this any other thing, but I don't care. What I know is that once I get my answer finished, I add up everything. So let's say this time the powers is what I'm adding, and the power, I'm referring to the powers as x. So I have log 5 to base 100. 2 go here, 2 go here, 50, 2 go here, 25, 2 go here, 1. So I actually have log 1/25, log 5 to base 1/25. What do I add to 1/25, which is the base, to get 5? This is the same thing as saying 25 raised to power minus 1 x equals to 5. This is the same thing as saying 5 raised to power 2 minus 1x equals to 5. This is the same thing as saying 5 raised to the power minus 2x equals to 5. This is the same thing as saying, since the bases are the same, and notice that as this thing is standing on its own, it's raised to the power 1. It is standing on its own, it's raised to the power 1. So bases the same. I have minus 2x equals to 1. So divide both sides by minus 2. So x is equals to 1 over x is equals to minus 1 over 2, which means that to add it up, to add up this log, and this log, that's what they're asking me. The log is the something as saying adding the powers. So 2 plus minus 1 over 2 plus minus 1 over 2. This is the same thing as saying 2 minus 1 over 2 minus 1 over 2. LCM is 4. 8 minus 2 minus 2, that is 4 here. 4 here. 4 divided by 1, 4 times 2, 8. 4 divided by 2, 2 times minus 1 minus 2. So this is going to be the same thing as saying 8 minus 2. First of all, minus 2 is minus 4. Minus it from 8, you have 4. Or you say 8 minus 2, 6 minus 2, 4. 4 over 4. So your answer is 1. That's how you go about that. So we have, if 2 log 8, if 2 log 8, then 2x minus log 8y is equals to 1. Express x in terms of y. So whatever they are telling you to express in terms of anything should not confuse you. It's not your business. So just come and remember that what you just need to do is to apply the laws of logarithm. That's what you should have in your mind. So 2 log 8 2x is the same thing as saying log 8 2x. Sorry, log 2x to base 8. I normally make that confusion. Don't get carried along. So this is going to be the same thing as saying log distributive power law 4x squared to base 8. Now minus log y to base 8. So minus log y to base 8 equals to 1. And notice that this is base 8, this is base 8. If I do log 8 to base 8, it will still give me the same 1. So it's important. Assuming this is log 10, I'll still do log 10 to base 10. These are certain things, certain principles that logarithm want us to be aware of. So whenever you're solving any topic, you'll be, or should I say, paying attention to the way that kind of topic behaves. So I have minus here. This is the same thing as saying bring the log one side, 4x squared all over y equals to log 8 to base 8. So see that I have log 8 here, I have log 8 here. This, take care of this. So I now have 4x squared all over y is equals to 8. So now 4x squared is equals to 8y. So I can say divide both sides by the coefficient of x squared, which is 4. 2 here, 4 here, 1, 4 here, 2. So x squared is equals to 2y. And notice I can say take the square root of both sides, so that this becomes x squared, square root of x squared is 2y root 2y. So this will cancel this. So x, so what that express x in terms of y is saying is simply make x subject of the formula, or find x. So x is equals to 2 y. Assuming they said express y in terms of x, notice that what we could have done is simply x squared. Y could have been y equals to x squared over 2. Alright. So the next one, they said log y to base 2 is equals to log v to base 4. Notice that these two bases are different. The values are different. So this is where you apply equality law. Or that one I told you, base law, equality law actually. So for the fact that they have nothing in common, I'll simply say let each person carry its cross. So let's say all of it is equals to, since they said this is equals to this is also equals to x. Reason being that I will need to know that I'm asking myself, what do I add to this base to get y, which is the same thing as saying 2 raised to power x is equals to y. And this is equals to, what do I add to this base? So if this will confuse you, just focus on it this way, just this way. So I'll ask myself, what do I add to this 4 in order to get v? Because that's what logarithm is all about. Once you need to get to the idea that if you see the log, you can throw it away by saying the base raised to what power? Here we are using x, will equal to the given number. And notice that this thing that I have here is the same thing as saying 2 raised to power 2x is equals to v, which is the same thing as saying 2 raised to power x raised to power 2 is equals to v, is equals to y equals to 2 raised to power x. Now notice that the question said express v in terms of y without involving logs. We don't even need to involve logs. So expressing v in terms of y now, this is v, and that is why I did this thing. Notice that y is equals to 2 raised to power x, which means that v is equals to y raised to power 2. Since the value of y is 2x, is 2 raised to power x, y v is 2 raised to power x squared. So it means that v is equals to y squared. Alright, so question 5, they said log x to base 9 is equals to 1.5. I know you know that one. It's simply the same thing as saying just say this as it is here. They've put 1.5. Sometimes it gets confusing. So remember, this time around, they're telling me that everything I have here is equals to 1.5. And remember, this thing that I have here is the same thing as saying initially 9 raised to power x should give me what, which is equals to x. But now my x, this particular x, if I'm taking it to this place, if I'm taking it out, remember that first of all, mn, now when I have mn equals to m raised x raised to power a, that, or should I say, let me use n. Now this is the same thing as saying this one becomes the log, the base, this one becomes the power. Are you seeing it? So if, and this becomes the number I'm finding, this becomes the number I'm finding, and this becomes this way. So notice, if we use this approach, I have a number, and the base raised to this power gives me this number, which means that the log of this number to this base, which is x here, will give me this power. So for that reason, let's apply the same approach here. So I now see that if I have log 9x equals to 1.5, let's check. Let's try to convert this now. That means that I can bring x to be n here. X equals to, what is the base? 9. See it. Then what is here? and here. Look at where it is. So you see it. So that is why I'll simply solve this by doing x is equals to 9 raised to power 1.5. And remember that we don't like making use of 1.5, so of decimal. So we'll take it to fraction. This is the sentence. So this is the sentence x is equals to 9 raised to power 15 over 10. 5 can go here to give me 3. 5 can go here to give me 2. X is equals to 9 raised to power 3 over 2. And applying indices, denominator becomes roots and numerator becomes power. So this is the sentence saying x is equals to 3 raised to power 3. X is equals to 27. Very simple. So if I know that, let's see if we can solve another one. That's it. So I can simply solve this one. Log 2x plus 1 divided. So I can simply say that division is the sentence saying that subtraction, since it's this way, it means that they are in base 10. So all over 3x minus 2. Log 1 is the sentence saying anytime I see equals to 1 or equals to something, the other side, I can simply say, so far as this is 1, in this case, once I see 1, I just say there's a log for 1. So log 10 to base 10. Log 10 to base 10 is the sentence as 1. So I can see clearly that this will take care of this. So that I now have 2x plus 1. Remember, is this one we are solving. So 2x plus 1 is equals to 10. So since then is going to cross multiply. This now becomes 2x plus 1 is equals to is equals to 10 into 3x plus 2. So 2x plus 1 is equals to 30x plus 20. Collect line terms. This will become 2x plus minus 30x plus 1 minus 20 equals to 0. This will become the sentence as saying 20 minus 28x. Yes. Okay. Let's say I leave it this way. Let's say I did it this way, equals to, watch. Okay, but whichever way, let's just leave it the way it is. So notice that this is plus. Shebi? Okay, yes. So see, we have minus here. We now change our own to plus. It's wrong. So this is minus, this is minus. This is minus. So notice that when it times, it will become minus 20. It's just the minus that we are trying to impute. So that means that this is going to be plus 1 plus 20. So which is going to give me plus 21 equals to 0. So notice that minus 28x can be equals to 21 in minus. Shebi, that is if you cross equality sign. This cancel this. So I have 28x equals to 21. X is equals to 21 over 28. And that means that x can be equals to 3 over 4. That is, yes. if 28 is divided by 3, you will get 4. And if 21 is divided by 3, you get 3. So there you have it. No long thing. It's not a big deal. You just need to get it that what we have there is minus. You don't confuse it. Alright. So let's try to see the next one. So see your assignment for me. Let's just finish it. So if I have the next one, they said log x to base 2 and log x plus 3 to base 2. So I'll simply say, since they're in the same base, I just say log 2 x into x plus 3 equals to log 2 to 4. Notice that this, this is going to be x squared plus 3x equals to 4. This cancel this. So I have x squared plus 3x minus 4 equals to 0. I have a quadratic equation. So I can use minus b plus or minus b squared minus 4ac all over 2a to solve this. Are you seeing it? Or I can just do, let me use this, x squared plus 3x minus 4 equals to 0. I can still use factorization. Let me see. If I do this and this multiplied, it will be 4x squared. And I have plus sign here. If I have, what do I do to this so that I can get this middle term and still have that is this times this, 4x squared. Now what do I get that will give me 4x squared and still give me, that is when I multiply it will give me 4x squared, and when I add it gives me 3x. Let's check. If I have remember that this is minus 4x squared. So 4x times x minus x is the same thing as saying minus 4x squared. And 4x minus x will give me 3x. So let me just come and replace it. I have x squared plus 4x. So I'm replacing the middle term, which is 3x, with this minus x minus 4 equals to 0. So let's factor out. In factoring out, how I like to do my own is this way. I will say this first, this one. So notice that right here I can see x and I see x. Let me bring out x. Let me bring out x. If I bring out x, x times x is x squared plus 4. X squared 4x, then minus, here I have x and I have 1 and I have 4. If I bring out 1, I'll make sure that I don't need to do stressing myself. Once I factor out what is for x here, I don't need to stress myself. Just come and replace what you have here as well. Because if you do minus 1 times x minus x, minus 1 times 4 minus 4, so equals to 0. So I have x minus 1 and x plus 4 equals to 0. So this formula is formula method, but I don't want to use it. I just want us to use factorization. So we'll see that this is the sentence as saying x is equals to 1 and x is equals to minus 4. And in logarithm, we don't normally see log of negative number. So we can accept x equals to 1. Not so this is this, but we can accept this and not minus 4. You need to know that. So, and you remember that I told you that anytime the highest power is 2, for any expression, if the highest power is 2, you always get 2 solutions. But here we are using this. Alright, let's go to this one. They said log 3 of x plus log 9 to base x. Sorry, log x to base 3. Then log 9 to base x is equals to 3. You're supposed to solve one as assignment, but let's just log x to base 3 plus log 9 to base x is equals to 3. If I say solve this one as assignment now, we'll have issues. Okay. What do I know? Okay, I can simply say this is what I have here. Let's check. What I have here and what I have here, they don't have business. This is x, this is 3. But I know that if you check this well, this can be the same thing as saying, this can be the same thing as saying 3 raised to power x is equals to x. And this can be the same thing as saying x raised to power let's say y is equals to 9, then equals to 3. So, but I know that okay. What this thing means is this: 3 raised to power x is equals, that is, what do I add to this base to get x, and what do I add to this base to get 9? So I can very well see that 9 is 3 raised to power 2. That means this is x raised to power y is equals to 3 raised to power 2. So I can simply say, write this with something as saying log x to base 3 plus this log 9 is the same thing as saying 2 log x, 2 log 3 to base x. If you remember, this is log x 3 raised to power 2. Using power law, it will come over. That is what I did here. So I can remember that there is a law that will prove somehow. We proved one law when we were doing this. That we said if I have log 2 to base 3, because they have nothing in common, if I make this way, I can choose to introduce this log of this so that this becomes 1. And that by the time I finish everything, I am now having 1 over, you see I reversed it, is now log 2 down, and is now log 3 that is the base. That is log 2 that is the base at the end of everything. Remember when we solved this. So for that reason, I'm trying to make sure that for that reason I can have this to be called the same thing as saying 2 one side. Then let me say x. Now let's say to y power equals to 3. What do I add to x to get 3? So I will now have that. This will simply be the same thing as saying, remember this one is one side, I'm keeping this one side. So this is the same thing as saying log of 3 to xy and log of 3 that is base log to base 3 to both sides, so that this will become 1. So this becomes 1 equals to log 3, that is y log 3x. This one moved over. I kept the 2 one side. So you see that by the end of the day, at the end of the day, this is now the sentence saying divide both sides by log 3x. Log 3x. So this will cancel this. So I now have y to be equals to, but remember that I am the one that introduced this y. So for that reason, so I now have I now have times this, it now becomes 2y is equals to 1 over log x3. So what it means is simply, I used y here. So but what it means is that if I have this thing now, everything here is simply the sentence saying 1 over log 3x. So we can always reverse. That's what I'm trying to say. So this is now 1 over. So if I have log BA, this is the sentence saying 1 over log AB. That's what I'm trying to say. So let's now substitute what we now know. This is now going to be log. Let me rewrite it. 3x plus 2 into 1 over log x to base 3 equals to 3. So notice that I can now say, using mathematics initiative, I can now say, since what I have here and what I have here is the same thing, I can say, let me call these two things, let's say k. Let k be equals to log x to base 3. So you need to note this principle. Log a to base b is the same thing as saying 1 over log b to base a. Is the same thing, which means that log 9 to base 3 is the same thing as saying 1 over log 3 to base 9. Alright, we'll come back to prove that. So I now have this. If this is k, if this is equals to this now becomes k plus 2 over k is equals to 3. So notice that once I have plus here, LCM takes place. So I have k into this, it becomes k square plus 2k, that is, sorry, k into this will be 1, 2. Are you mad? Sorry. Equals to 3. So this is now k square plus 2 all over k equals to 3. It is standing on this over. So I now have k square plus 2 equals to 3k. Notice that at this junction, I can now have k square minus 3k plus 2 equals to 0. And this is a quadratic equation. So at this junction, I want you to solve the quadratic equation as your assignment. So solve this as your assignment. And remember that after you solve the assignment, you will still come back and remember that k is equals to something. So you now do when k equals to this and when so solve. Let me see your answer. Alright, let me try to check this thing that I did here. Log 9, first of all, this is going to be the sentence saying 3 This is going to be the same thing as saying 3, this end, 3 to what power x is equal, will give me 9. So 3 raised to power x, 3 raised to power 2. This is going to be x equals to 2. Now let's check 1 over. 1 over log 3 to base 9. This is going to be the same thing as saying 1 over, sorry, first of all, let's bring the log out, then we'll go back to this. It's going to be 9, which is the same thing as saying to what base will give me 3. 9 to what base will give me 3. What do I add? Sorry, to what power? What do I add to 9 in order to get 3? Is half, 1 over 2, or taking the square root. So notice that square root of 9 will give me 3. Is it not true? So if the square root of 9 will give me 3, let's try to do it. If I take the square root, I get 3 equals to 3. Then remember that I have over 1 here. Should be over 1, which means that what I will have here is going to be square root 1 over the square root of 9. And that should be, let's be sure. Okay. And this is now going to be the same thing as saying, let's apply. This is going to be the same thing as saying 1 over 3 raised to power 2. Raised to power 1 over 2. Which is going to be the same thing as saying 2 cancel 2, 1 over 3. I'm just confusing myself. See, this thing that we did here, gave us 9 raised to power 1 over 2, which means that the log is 1 over 2. It's 1 over 2 I'm looking for. So I will carry it back. See, log 9 to log 3 to base 9. I'll carry it back to give me 1 all over 1 over 2. That is just what I need to be there. The power is what I need, not this thing that I'm doing here, because this one that I'm doing here is simply when I did log 3 to base 9 gave me the sentence as saying root 9, and root 9 is the sentence as saying, this root 9 is the sentence as saying that 9 raised to power half will give me 3. Shebi 3, which is what we have here now, will give me this 3. So I need to now check if it's true by doing this 1 over the power. Remember that that's what logarithm. Everything here log 3 to base 9 is 1 over 2. That is what it means. Log 3 to base 9 is 1 over 2. So 1 over 1 over 2 will be the same thing as saying 1 divided by half, which is the same thing as saying 1 times 2 over 1, which is the same thing as saying 2. So notice that this 2 is the same thing we got when we did for this. So that means that log 9 to base 3 is the same thing as 1 all over log 3 to base 9. This one, this thing, this logarithm, everything here will give me 2. And everything here, the answer, the log of 9 to base 3 is 2, because 3 raised to power 2 is 9. And the log of 1, the log of 3, 1 over, 1 over log of 3 to base 9 is going to give me 1 over 2. Because first of all, log 3 to base 9 is half. So when you do this, you still get 2. So you need to know that. The last one. They said 3 raised to the power x plus 1 equals to 15. Notice that somebody will see this and want to do indices. But notice there's nothing common between the two here. You can reduce 15 to 3. So for that reason, I just add base to it. I'll just add logarithm to it. Log 10 to 3x raised to the power plus 1 equals to log 10. That's log to base 10. So log 15 to base 10 and log 3 raised to the power x plus 1 to base 10. So notice that the minute I do this, this becomes the power. Applying that power law, x plus 1 log 3 to base 10 equals to log 15 to base 10. I seen it. So at this junction, I will need to look at it again. I will see that, let me collect like terms. I see that x plus 1 will be equals to log 15 to base 10 minus log 3 to base 10. Division law, this becomes log 15 all over 3 equals to x plus 1. 3 here 1, 3 here 5. So this becomes log 5. Or I can choose to say, yes, so I can find log 5, and whatever I get for log 5, remember that I have x plus 1. So I will now do x is equals to log 5 minus 1, and x should be equal to 1.4651. So thank you for watching. Remember to like, share and subscribe. So